Picture this. You've got a rogue autonomous agent literally 4,000 lines deep into your enterprise codebase. It is currently wielding full bash execution privileges, it has complete write access, and it has just suffered a catastrophic neurological failure. It has completely forgotten why it's there. It's basically holding a digital blowtorch, and it genuinely doesn't remember who hired it. And this is the system you're about to trust to run your company's entire backend. Welcome to the existential terror of AI orchestration. 96.7% versus 6.7%. Just let the sheer staggering absurdity of that massive performance gap wash over you for a second. That completely abysmal 6.7%, that represents standard conversational AI agents trying to write code. They are digital entities that essentially suffer from anaerograde amnesia. But the 96.7%? Those are the Opencode agents that actually survive their own memory wipes purely because they bother to write things down before their short-term memory inevitably detonates.
We're looking at the actual boots-on-the-ground reality of how modern AI writes software. Specifically, we're talking about something called Stateful File-Based Orchestration. Now let me set the stage for you, because we live in a very, very strange era. We have artificial intelligence that has essentially ingested the sum total of all human knowledge. Right? It can write poetry that'll make you cry, it can solve complex math that completely baffles university professors, and it can engineer entire software applications from absolute scratch. And yet, if you've actually spent any time using these advanced coding agents for complex, long-running projects, you've probably noticed something deeply, deeply contradictory. These systems are unfathomably brilliant, like alien-level smart, but they possess the situational awareness of a highly caffeinated, completely distracted toddler. Seriously. So let's dive into exactly why that is, and the absolutely absurd ways engineers are trying to fix it. So, we have to start by exposing a fatal flaw in modern AI. It's a phenomenon known as Goldfish Memory. This is where an AI, again, a system holding the sum of human knowledge, suddenly suffers from gold drift and just completely forgets its objective mid-task. Why does this happen? Well, here's what is actually going on under the hood. When you interact with an AI, you are operating within what's called a context window. I want you to think of this window as the AI's short-term memory, or maybe like a digital whiteboard. As the AI reads your code, runs bash commands, searches the web, and generates text, it's writing all of that on the whiteboard. And the whiteboard is filling up, because even the most advanced multi-billion parameter transformer models on Earth have a hard, physical limit to how much data they can hold in their active memory. Eventually, that whiteboard gets completely full. When that happens, the system has to compact that memory or sometimes just wipe the board entirely to make room for new thoughts. And when that happens, the AI effectively blinks, looks around the digital room and goes,
Wait, what were we building again? A banking app?
I kind of feel like we were making a multiplayer Snake game. It's wild. This information loss leads to transient tool outputs just vanishing into the ether. The AI wanders off topic, and entire project architectures collapse simply because the AI literally forgot step 2 while it was working on step 7. It is a certified genius, but it's a genius with a leaky bucket for a brain.
Look, grab a coffee. Actually, you might want to grab 3, because today we are aggressively roasting the goldfish memory of standard AI coding agents. You know the pain I'm talking about. You hand an AI a complex task, and it's absolutely brilliant for about 10 minutes. And then boom, it forgets your tech stack, it hallucinates non-existent libraries, and it nukes perfectly good code. It is completely maddening. But today, we end it. I'm giving you the 100% actionable, no BS technical roadmap to fix this by building a persistent agentic workflow. No more amnesia.
Just a bulletproof system. Let's start with the core philosophy of why your AI keeps hallucinating. It's a fundamental paradigm shift.
You have to start treating the AI's context window as volatile RAM. It's fleeting. The second you clear that chat or hit a token limit, it wipes completely clean. So to fix the amnesia, we have to rely on a permanent hard drive, which in this case is your project file system. We are literally forcing the agent to write its thoughts, its plans, and its learned mistakes directly to markdown files on disk. If it's not written to the file system, it basically doesn't exist. Ground Zero setup. Okay, you must execute this exact sequence to get up and running. First up, you pull the core Opencode architecture using the standard curl script. Next, you launch the terminal UI and run the /connect command to authenticate your AI provider. Easy enough. Step 3 is the absolute linchpin. You need to inject the file planning capability using npx. Now, using the -g flag installs it globally across your system, so it's everywhere. But if you omit that -g, it just installs locally right into your .opencode/skills directory. That's actually perfect if you want to isolate some experimental behaviors in a specific rebog. Once the core is humming, we handle the project itself. Whether you're spinning up a totally fresh directory, let's call that scenario A, or you're retrofitting some massive legacy codebase in scenario B, running the /init command is strictly required. For a new project, /init basically acts as an interview, asking clarifying questions to map out your new structural DNA. But for an existing repository, oh man, it is absolute magic. It scans your codebase, identifies your build tools, figures out your testing conventions, and bakes all of that context straight into your project's agents.md file. It maps the legacy architecture instantly. But wait, before we move on, we have to fix the permissions. You absolutely must set these exact JSON permissions in your opencode.json file. If you don't explicitly set both planning with files and prud to allow, your AI is going to constantly nag you for approval every single time it tries to read or write a planning file. Seriously, we want an autonomous engineer here, not a needy intern. Just drop this JSON in your config and let the agent do its thing. So, Opencode uses this layered concatenation strategy for instructions, and understanding this hierarchy is absolutely vital. Number 1, your local project rules. These live right in your project root and have the highest priority. Number 2, your global developer habits. These live over at your ~/.config directory. These are your universal habits, stuff like always use pnpm over npm. And number 3, config instructions. Since these files are concatenated together sequentially, your specific local project rules are read first, which is brilliant because it ensures your local project rules always override your global developer habits. It keeps the AI hyper-focused on the immediate constraints of the repo you're actually in. Let's talk best practices for that agents.md file. Look, if you bloat this file, you are bleeding tokens and totally destroying the AI's signal-to-noise ratio. Keep it ruthless. Enforce a strict 200 to 400 line limit. And since LLM attention mechanisms heavily prioritize the top of documents, put your non-negotiable architecture rules right at line 1. For monorepos, you can use nested agents files in specific folders for progressive disclosure. Oh, and my personal favorite trick, inject canaries. A canary is basically a booby-trap instruction, like whenever you read this file, always summarize the current git status. If the AI doesn't summarize the git status, well, you instantly know it completely ignored your rules.
This setup, the PRD steering wheel, and the swarm. Let's look at how developers are actually attempting to solve this amnesia. To solve this massive memory problem, developers introduced a multi-agent architecture in the Opencode environment. And honestly, the best way to describe this is that they built a rigid, micromanaged corporate hierarchy for robotic interns. You see, you don't just have one AI doing everything anymore. That's way too dangerous. You have a highly specialized swarm. As this table brilliantly illustrates, we've broken the workforce down into 3 categories. First, you have the build agent. This one uses your heavy reasoning models. Think of this agent as the muscle of the operation. It has full tool access, it can create and delete files, it can execute bash commands, it is the one actually swinging the hammer on the digital construction site. But because we know the build agent has Goldfish Memory and might suddenly get amnesia and accidentally delete your entire production database, we simply cannot let it work unsupervised. Enter the plan agent. This is your analytical, high-context model. It's essentially the overpaid consultant of the swarm. It has heavily restricted access. It can only read and analyze. Its entire job is strategic planning and code review, forcing a strict review before action workflow so the build agent doesn't go completely rogue. And finally, at the bottom of the ladder, you have the explore agent. This is a fast, lightweight model doing read-only reconnaissance. It's the terrified intern you send down into the dark basement of the codebase with a flashlight and a pair of binoculars. Its job is to quickly scan 10,000 lines of code and report back to the consultant without touching a single thing. Now, the core issue here is the psychology of managing these specific agents. To keep these brilliant but highly literal-minded agents from just destroying your project, they require a flawless product requirements document, the PRD. This acts as their steering wheel, because otherwise, as the quote goes, they will exploit any vague instruction like water leaking through cracks in concrete. This is a profound realization about working with artificial intelligence that a lot of people miss. If you tell a human engineer, hey, build a login page, that human instantly infers 1,000 unspoken cultural and technical rules. They know you need a password reset button. They know you need error messages if the password is wrong. They know the background probably shouldn't be bright glowing neon green. But if you tell an AI, build a login page without a strict PRD, it might build a login page that only accepts the exact word password because, well, you didn't explicitly tell it not to. It's like dealing with a genie who is actively trying to trick you. To fix this, Opencode uses something called interview mode, where the AI actually interrogates you first to uncover all your hidden requirements and technical constraints. It then translates your messy human desires into a hyper-strict markdown file. The PRD becomes the absolute, undeniable law of the land. It is the only thing that stops the swarm from wandering off into the digital wilderness to build snake games. The deep explanation. The shift to persistent memory. Now we get into the really clever architectural hack developers use to permanently fix this. So how do you cure digital amnesia? You force the AI to physically write notes to itself in markdown format. I know that sounds incredibly anticlimactic, but it's brilliant. An AI's context window is just volatile RAM. It constantly leaks. Those ephemeral chat-based instructions you type into a text box, they are practically useless for long-running complex engineering tasks. The project's file system, however, acts as a permanent concrete vault of working memory. It survives session lifecycles. If the AI learns something incredibly important during its reconnaissance, it cannot just hold it in its mind, because we know its mind is going to be wiped in about 10 minutes anyway. It has to save it to disk. What we are seeing here is a fundamental shift away from a chat-based assistant paradigm to a stateful, file-driven orchestration. The AI is now interacting with the file system the exact same way a human interacts with a physical notebook. It reads, it writes, it saves. And the results of this architectural shift? They are absolutely staggering. By moving from a chat-based memory to a stateful planning with files paradigm, the AI success rate on complex engineering tasks skyrockets from a miserable 6.7% to an incredible 96.7%. Just let that sink in for a second. We took a system that was failing 93% of the time and turned it into a nearly flawless engineering machine. And here is the craziest part. The underlying intelligence of the AI didn't change at all. We didn't invent a vastly smarter neural network. We didn't uncover some secret magical algorithm. We literally just gave the digital goldfish a notepad and forced it to write things down before its memory reset. That single, seemingly simple architectural constraint, treating the local file system as the ultimate source of truth, turns a chaotic, failure-prone chatbot into a highly reliable, autonomous engineering swarm. It's almost insultingly simple. So how exactly does the AI write things down? This miracle cure is achieved through what is formally called a functional triad of markdown files. Think of these three specific files as the permanent external hard drive for the AI's brain.
The execution loop. With our guardrails firmly installed, we enter the holy trinity of preventing scope creep. Listen, throwing a vague PRD at an AI is exactly like water exploiting cracks in concrete. It will find the ambiguity and it will break your app. That is exactly why we meticulously step through this sequential loop. Phase 1, we use the /PRD command to enter interview mode. This forces the AI to ask us clarifying questions until we've got a rock-solid PRD. Phase 2, we hit the tab key to switch into plan mode. Here, the AI generates our vital 3-file system, a task plan for the roadmap, a findings file for the research dump, and a progress file for the log.
First up, we have task_plan.md. This is the strategic memory. It holds the major architectural milestones, dependency maps, so the AI doesn't try to build the roof before pouring the foundation, and crucial status markers like complete, in progress, or blocked. Second, we have findings.md. This is for tactical research. Remember our Explore agent, the intern in the basement? When it runs a massive search through tens of thousands of lines of code, the output goes straight into findings.md, so it's not lost forever when the context window inevitably clears. And third, we have progress.md. This is essentially the AI's personal diary or maybe a confessional booth. It is a meticulous session log recording every single command the AI runs and every single error it encounters. This triad allows the swarm of agents to perfectly coordinate complex multi-system changes that would be mathematically impossible to hold in a single conversational context window.
And only after those 3 files physically exist on the hard drive do we hit tab again for phase 3, build mode. That's where the AI finally executes the verified plan.
The absurdity, the iron laws of verification. Because this is where the micromanagement of these models becomes genuinely hilarious.
So let's see what happens when the AI actually attempts to finish a task. Spoiler alert, it is not allowed to just say, I did it. It must pass through the verification gate. Identify, run, read, verify. These are the iron laws of implementation. It's an obsessive-compulsive ritual that the AI is forced to perform, essentially at gunpoint, by a squad of reviewer subagents. Only after providing cryptographic-level proof of passing tests is it actually allowed to claim it did its job. Let's run through these operational rules with the respect they deserve. Create plan first. Read before decide. Update after act. Never repeat failures. I am delivering these to you with the frantic, sweat-inducing intensity of a hostage negotiator listing demands to a highly unpredictable captor, because that is exactly how the software treats the AI. Obey the rules, or the loop terminates.
You see, because AI can so easily get distracted or just stare blankly into the digital void, developers had to implement some absurdly strict babysitting rules inside the project's instructions. Enter the hilariously specific to-action rule. This rule literally forces the AI to stop what it's doing and document its work after just 2 view or search operations. Why? To prevent it from getting lost in thought and forgetting everything it just read when its memory compacts. I want you to imagine hiring the absolute smartest, most capable engineer on planet Earth, but you have to install a shot collar on them that buzzes every single time they open 2 browser tabs, forcing them to physically write down what they just saw before they forget it. That is exactly what developers are doing here with automated scripts called software hooks. Because without it, the AI will happily read 50 files, completely fill up its context window, and then silently crash, destroying all of its own research. The to-action rule ensures the AI's short-term findings are safely locked in the concrete vault of the findings file before the inevitable amnesia hits. And the micromanagement escalates even further with the operational rules of this persistent planning pattern. These aren't suggestions, these are non-negotiable laws. Create plan first. No complex task is allowed to begin without a task plan file, period. Read before decide. The AI literally has to be commanded to reread its own plan file before making any architectural decision, just so it keeps the primary goals in its active attention window. Update after act. Immediately log all status markers. But my absolute favorite is the never repeat failures rule, which is also known as the 3-strike error protocol. If you've ever watched an AI agent fail at a coding task, you know it has a baffling, deeply human tendency to stubbornly run the exact same broken bash command 20 times in a row, desperately hoping for a different result. The 3-strike protocol strictly forbids this madness. It forces the AI to track the attempt, officially document the failure in the progress file, actually diagnose the root cause, and completely rethink its life choices after 3 strikes. We literally had to write rules to prevent supercomputers from throwing tantrums. And the paranoia doesn't stop there. To prove they actually did the work they claim they did, agents are locked in a mandatory verification gate loop, and they cannot escape this cycle until they prove to specialized subagents that they didn't just break the entire codebase. This is governed by the iron laws of implementation. The build agent can't just write some code and say, boom, I'm done, it looks great to me. No, It must first identify the relevant tests, run those tests, read the output, and verify the results against the original PRD success criteria. If it fails, it is trapped in a mandatory fix and re-verify loop. It literally has to submit its homework to a code quality reviewer subagent and a spec compliance reviewer subagent. If those highly critical, judgmental subagents don't approve, the primary agent is denied permission to move to the next phase. Think about that. The AI is simultaneously playing the role of the brilliant developer and the ruthless quality assurance inspector, aimlessly battling itself inside a digital sandbox. The big realization: swarms and semantic memory. Let's pull back and look at the massive implications of where this architecture is actually taking us. This all brings us to a profound realization of how we have to manage the overall lifecycle of these agents. Because context windows are limited, a single AI session simply cannot build a massive application from start to finish in one go. It's impossible. You have to kill the session and start a new one. But how does the new AI know what the old AI was doing? Well, when a new AI session starts, it generates a catch-up report. It basically forces the new robotic intern to sit down and read its dead predecessor's diary. The system automatically checks the session store, looks at the delta between the last file write and the current codebase, and synthesizes a brief. This allows the new agent to sync its internal state, recover that precious short-term memory, and seamlessly resume work without any ambiguity. And this is how you effectively orchestrate an open-code swarm over months of development. Every single task feeds into a massive semantic memory. If one AI solves a really complex debugging issue on Tuesday, it saves the root cause and the solution to disk. The next time a completely different AI in the swarm hits a similar roadblock 3 weeks later, it can do a semantic search, find the old AI's notes, and instantly bypass the problem. The swarm literally learns and gets smarter over time, even though the base model hasn't changed at all.
This leads us to the catch-up report mechanism, which is frankly one of the most eerie processes in modern computing. When an agent's context window inevitably dies, a new agent is spawned. This newly born entity then reads the file system to inherit the exact state, thoughts, and memories of the agent that just died. It is a continuous cycle of digital reincarnation, mediated entirely through text files. And the new agent? It's trained using this, memory.md, a persistent markdown table of shame. It meticulously logs every avoid mistake and every adopt preference, ensuring that when the multi-agent swarm wakes up tomorrow, it doesn't repeat the exact same humiliating failure that literally killed its predecessor today. We drop this right in the project root. It acts as a persistent database of corrected mistakes, complete with columns for date, topic, the mistake to avoid, the preference to adopt, and the context. When the AI messes up, we don't just quietly fix the code for it, we literally mandate that the AI updates this table. That way, the correction persists across sessions, surviving any of those context window wipes. And how do we actually enforce that? With a highly precise trigger command. When the AI slips up, say it uses standard print statements instead of your preferred logging framework, you hit it with this exact prompt. That's not quite right. You used X, but we use Y. Log this in memory.md according to the protocol and fix the code. Bam! This abruptly pulls the agent right out of its coding flow and forces it into structured data mode. It logs its own failure to the hard drive, meaning it literally never makes that mistake again. It's beautiful.
So, the crucial point we have to understand is that the entire philosophy of software development is undergoing a massive fundamental shift right now. We are moving away from humans manually building plans to building features, where the architectural strategy lives permanently inside the file system and travels with the code itself. Think about how we used to do it. In the past, a human product manager would write a plan in Jira or a Google Docs somewhere in the cloud. Then, a human engineer would read it and eventually write the code. The plan lived in one place, the code lived in a completely different place. Today, in this stateful paradigm, the markdown files, the PRD, the task plan, the findings, sit right next to the source code directly in the repository. The AI reads the markdown, writes the Python or TypeScript, updates the markdown to reflect the changes, and commits it all together. The steering wheel is bolted directly to the chassis. The plan and the product are essentially becoming the exact same thing. Which leaves us with this slightly sarcastic yet deeply philosophical question to end on. As we move toward this full process agentic collaboration, have we stopped being developers? Have we simply become glorified validators for an endless swarm of highly capable yet deeply forgetful AI interns? I mean, really think about it. If the AI is writing the code, and another AI is reviewing the code, and a third AI is writing the diary of how the code was written, what exactly are we doing? According to the experts, the human role is elevating. We are moving from low-level implementation to high-level strategic validation. We set the guardrails. We write the initial prompt. We approve the final PRD. And then, we basically just sit back and watch the swarm logically argue with itself in markdown files, occasionally stepping in when the two-action rule catches an AI staring blankly at the wall. It is an incredibly powerful, incredibly strange new paradigm. We have conquered the limitations of AI amnesia, not with a multi-billion-dollar mathematical breakthrough, but with the digital equivalent of a post-it note. And honestly, it works flawlessly.
So, by combining the RAM to disk paradigm, the strict execution loop, and the long-term memory table, you have essentially built an AI that actually gets smarter every single time you correct it. Now that you possess the ultimate 100% actionable technical roadmap to persistent agentic memory, the only question left is, when are you going to stop repeating yourself, fire up your terminal, and finally implement?